So today we are going to talk about birds, and I sent out a paper early on today explaining to you why we should actually study birds. Oh, Ben is important. Here we go. Uh, and as this picture quite neatly demonstrates, and there's lots of philosophical research, psychological research, uh, and social research, is that people like birds. Now, there's something, and the psychologists quite debate the issue a little bit about birds and turtles. Here's a turtle. I hope it's not dead. Which basically attracts our sense of nature to the subject. And lots of people are engaged in bird watching, lots of people are engaged in documenting birds, and lots of people are engaged in bringing almost an artistic view to birds. And I have sort of chosen this particular YouTube clip here, which very, very neatly demonstrates the beauty people see in birds. And there's something to be said for that.
You can tell the sun is jealous sky. We will walk in fields of gold. So she took her love all to gaze away.
And watch this with sort of a sense of an open mind. And, it's probably a bit surprising for you that, here's Schlacher turning into an arty-farty social science kind of lecturer. But there's more to life, and there's more to science sometimes than just doing numbers. Although I had a Zoom meeting with one of the students just before we started off, and I explained that as a scientist, you simply have to embrace numbers. But that doesn't mean you can't actually embrace different philosophies just the same, and you can't actually embrace a deep artistic understanding of the subject matter. After all, I think many of us become biologists because we like to study that. We have some sort of intimate connection to what we actually want to do. Might be different for engineers, although some people actually like, working around, with that kind of stuff. But I think we biologists have the singular advantage, and it's almost a gift to work with really attractive subject matters. Right. Another reason we study birds, and I'd like you to keep an open mind about that, is I tried to illustrate it with that image here. There's a lot of them. And when you go to many parts of the world, particularly when it comes to very productive wetlands, they're full of birds. So there's a great biomass of living things, so to speak, in the sky. And there's, of course, the never to be underestimated cuteness factor. And I tell you why this is important. You can beat your head against the wall, study mullets, nothing wrong with mullets, I worked on mullets, or copyboats, or mysids, or whatever you think is ecologically important. Great idea. But when it comes to convincing the public why you want to conserve a particular habitat, most likely you're going to win your argument using images like this. You got the big eye, got the kind of cuteness factor, and people go like, oh. And I'm going to show you a few of those. And if you're not convinced by those, then it's very hard to actually convince you about needing to conserve nature for aesthetic reasons and ethical reasons using any other imagery. And the lesson you should actually take away from that is that don't discount it. Sometimes arguments in conservation are not only made by numbers. There's another one, it even got a little crustacean, which we talked about in the lecture on sandy beaches, the ones who actually hop around and do all these amazing behaviors. Now, I put, or you can actually just go to the link here, the spruce, and there's a very hilarious article about twitchers. Do people know what a twitcher is? Does anybody know?
Yeah, they're fanatical bird watchers, aren't they? They travel all around the world to find new, different species they haven't seen before.
That's right. Not only are they fanatically bird watchers, but literally their only aim about bird watching is to make the longest possible list. And I think the world record stands at 6,385 species spotted by one guy in 1 year. It was a crazy Dutchman. And I always thought, like, well, it's a very, British thing, to be a twitcher. And a few years ago, we, had a very nice symposium in a country manor house. It was all like very, very, very posh in the middle of England. And then we said one Saturday afternoon, we said, oh, let's go down to the mudflat and have a look at it. It was actually a King's Lynn, if anybody knows that, but never mind. And there were hundreds on that Saturday morning of people doing nothing but staring out at the mudflat. So it must actually have some attraction to people for some reason. Now, here we have twitchers, and we have more twitchers, and we have more twitchers, and we have more twitchers. But I'm not showing you this image, because of all the twitchers, because I think it's particularly quite funny. The reason is there's hardly any marine or coastal environment you can go and you don't actually see birds. They're everywhere. And once you actually open your eyes to them, you even see more and more of them. Now, this is quite interesting here. This is actually a saline pond where they evaporate the seawater to make sea salt. But if you want to actually see a great diversity of waterfowl, ducks, grebes, herons, that kind of stuff, the best spot to go is to the sewage works because they float around in those pans. Even at Maroochydore down, where the markets are at Fisherman's Road, you can actually spot quite a few twitchers looking at the ducks. But the take-home message for you here as an ecology is birds are found in every singular marine habitat, except I just realized when I revised the lecture today, not in the deep sea, but otherwise they're everywhere. Now, one thing is also very convenient about birds is marine birds are shorebirds, and we will shortly talk about what shorebirds really are, have a very convenient behavior because when the tide is in, they all get pushed up to the upper beach and they concentrate in very large numbers in a few places. So if you want to observe birds and study them, it's easy doing it for shorebirds because the tide literally takes away at high tide most of the habitat and it compresses them into those high tide roosts. And not surprising then, high tide roosts are the most important bits of a habitat those species have, and they're also very vulnerable there because if you get a dog in there or a 4x4, they take out a large number. Now, I found that really hilarious little cartoon. What is a shorebird? We call them shorebirds. The American call them waders. Of course, in Australia, wader is like very, very long gumboots up with over the shoulders, which you actually use for fishing. But never mind. And as you actually can see on this picture here, on this cartoon, many of those wader things they look actually quite different from each other. Yes, they're all birds, but those little ones here, there are sanderlings, are waders, and so is the large whimperel here. And here's another whimperel. It's also a wader. So waders come.
Hey.
Yep. Yeah, Tom? Do you want to ask a question, Tom? No. Right. And, I find, when you actually write lectures, I try to update them every year a little bit, getting better pictures in and so forth, and new concepts, as you will see. You actually find that, and you can actually order a poster for $47 with different types of shorebirds. And it's actually quite a good one because it actually tells us there is no such thing as a singular type of shorebirds. Now, traditionally speaking, if you did zoology or ecology about 10 years ago, a shorebird was a species which belonged to a particular order called the Charadriiformes. And that Charadriiformes had 13 families. And if you go down that list here, we're talking about cicanas, snipes, gobbler is just a singular species from North America. Oystercatchers are a few. I like them really a lot. Ibis bills, stills, eversets, and so forth, and so forth. And here's sort of the plovers and the curlews and so forth. Now, let's actually examine this list in a little bit more detail to actually give you a feel of how many birds we would actually expect in the region here in Southeast Queensland. Now, traditionally speaking, if you buy the book Australian Vaders, and there's a new edition which just came out 2 years ago, they would say, well, those are our Vader species. We got a Chacana, and we got a snipe, we got an everset, we got a beach stone curlew, highly endangered. We got a plains wanderer, a petticoat, and an oystercatcher. And you say, like, yep, right, that looks about right. And you'd say, ooh, I actually study them because there aren't really all that many species. So if you're actually worried about having the pain and the labor and the difficulty, telling lots of things apart, and that is often, as a biologist, really, really difficult, you might say, oh, shorebirds, excellent idea. I go for that. Then it becomes a little bit more tricky because some of the smaller plovers, like those ones here, the red-capped plover, the lesser sand plover, and the greater sand plover, they can look quite similar, but you kind of get the hang of it after time, and you might say, well, those are numbers I can probably live with, and I can study that as a young graduate student, not a problem at all. And then he's like, ooh, I also get some really, really attractive study subjects, such as this guy here, whimper. Now, and I'll show you how the real world works. I always say to you guys, if you go to university and you expect any of us to go chapter by chapter by chapter by chapter of a textbook, then you're completely wasting your money and your time. And I'm wasting my time because you might as well sit at home and read it. There is nothing new we could actually tell you by teaching you out of a textbook. What we can actually teach you, however, is how to approach any work in ecology or whatever subject you choose by giving you real examples how it works. So I kind of looked at that list here about 8 years ago, and I thought, well, I cannot longer just work on plankton and fish. I need to actually get into birds, simply because we can't ignore them for reasons we actually have explored and will explore a little bit more. So I thought, all right, I love going to Morton. I love going to Stradey. And there's this small little village here called, what is it, Brisbane or something like this, some country hick town. And there's a big bay here. And I thought, right, what is known about birds in the region? And there's large bird clubs in all around here. There's a really big one here in Redland. There's the Queensland Vader Study Group and so forth. So I thought, my God, there is no place for me to do actually any work. But then I thought, all those islands here, we got a big long sandy beach, and we got a sandy beach here, and a sandy beach down here, and there's more sandy beach down here. What actually has been done about birds in a science sense on those ocean-exposed sandy beaches? So it turned out, bugger all, nothing. Nobody ever has studied it, and we are still the only ones. It's almost like sometimes you stumble at something, and you can say, "Oh, hallelujah!" That is actually a piece of luck. And the reason nobody actually studied birds on beaches because it's very hard. It's a lot harder than in those nice sheltered environments where the birds at high tide all go to a roost, because here, essentially, you have to walk or drive long distances. They're not as abundant and so forth. It's a lot harder. So everybody just actually did birds inside the bay and nobody went outside. So we thought, well, you know what? Bugger that. And so I had a student, Tara, and Tara is now working as a technician at the university. And we did something quite mad, really. Between February 2009 and May 2010, we walked 910 kilometers and we drove 6,000 kilometers up and down those beaches, counting birds like mad. And because I thought, okay, this is going to be over very quickly because there's not that many species and we're going to get the hang of it, very, very soon, and the data will be complete because we don't have actually anything more to add. Now, well, it turns out to be the case. We are still at it and learning something new every single time we go into the field. And straight away, we said, okay, this is the list which comes out of the textbook. And yep, we got oyster catchers. Yep, we got masked lapwings. Yep, tick. And we got, from the sandpipers, whimperers and so forth. All excellent. Done. But then we thought, right, what the people who count birds on the mudflats don't see, or very rarely see, is all what I call seabirds. And those are basically literally birds of the open ocean or of exposed shores who use the beach to feed in the surf zone or to rest. Now, don't worry too much about these complicated names here. I just put them down for my own benefit, really. But we got kind of the pelican-like ones, and we got the gulls, terns, skimmers, and auks. Then we got the tube noses, and so forth, blah, blah, blah. And we thought, okay, surely only 2 beaches in Southeast Queensland. Are we going to see any of those? Well, it turned out to be the case. They are not that rare after all. We got various boobies. We got the Australian gannet, and I just tell you, cormorants. And you might say on a sandy beach, yes, they actually roost on sandy beaches. We got egrets, pelicans. There was one pelican, his name is Moza. He always sat literally at the southern end of Stratford Island waiting, for fishermen to discard some bait. But where it really, really became interesting is when we actually started to count terns. And that was sometimes a little bit of a problematic business because there is lots of them. For instance, in that 1 year, over 20 trips or so, we got close to 12,000 requested terns, and we got gulls. And you might say, "Oh, why do you study gulls?" Well, gulls are now viewed by the proletariat, I should say, by the populace, as being a nuisance species. But that's not necessarily true. They're actually quite clever birds and are associated with humans because they actually learned how to scavenge food from us. However, on many of the beaches we investigated, they are a perfectly natural part of the natural bird fauna. So we had actually had all those. So that, right. But then you look up in the sky, and I would have never imagined that you find so many raptors on sandy shores. The reason for that is, if you look down, and many of you have actually done the assignment on that, if you look down a beach like this, and you probably have written about this by now, and I have now sent you papers and we discussed it via email, what the processes are. Let's think about it. If you are a scavenging or raptorial bird hunting little lizards or mice or whatever. Now you have an option of actually flying endlessly over the forests in the back here, or all you have to do is you fly along the beach here. Why would you want to do that? Well, everything basically which dies out here eventually lands up here at high tide, washes up. And you might say, I'm not so sure, Thomas, because every time I go to the beach, I don't actually really see many dead animals up on a drift line. How many dead animals have you observed lying there? I keep on saying that. But it's quite rare, isn't it? And the reason for that is we did a few experiments where we thought, okay, we're going to be very clever. So we put a fish here, we put a few of those wildlife trap cameras up there, and badum, it actually goes. And I think 80% of mullets which you put on the beach are gone in half an hour, because the raptors fly continually up and down and up and down. Because if you're an animal, you want to obtain food with the least amount of energy expenditure. So nothing better than a natural process which concentrates your food in a thin line. Plus, you can use the updraft of the wind coming in and then being deflected upwards from the dunes to glide along. It's literally the perfect raptor habitat. It's very hard to find a better one. The other ones are really up in high mountain ranges in the Andes or in the Alps, where we got lots of vultures. And essentially, they select their cliffs very carefully to have that updraft to take advantage of orographic lifts, and also the animals die. So quite often they hang around the edges really of agricultural areas, and we used to take cattle up to about 2,000 meters every summer for a couple of weeks. I show you the ones, the lopsided cattle which go around the mountain only one way. And so this, ocean beaches are a perfect raptor habitat. And guess what? Nobody has done any work on it ever. So, sometimes you can get not only lucky, but also you have to be observant what actually happens in the field. So we got all this. Yep.
Is that why birds will fly along the face of a wave when a wave's coming in?
Sometimes you see the white-bellied sea eagles coming there, and sometimes the ospreys. If you're up at Coolum, there's 2 or 3 ospreys which nest at Point Arkwright, and I have seen them sometimes to basically go out there.
Cool.
So we got all those birds of prey, and we thought, right, I don't really want to become, a bird ecologist. Surely that will do. But whenever I have international visitors and sandy beach, people who worked on sandy beaches all over the world, you take them to any of our beaches, not right here on the Sunshine Coast, but a little bit further up towards Double Island Point and Fraser, or south to Morton and Stray, and they simply cannot believe the number of raptors we have. It turns out to be the case that Southeast Queensland is quite a hotspot of birds of prey activity. We're not quite sure for the reasons, but I actually think because a couple of ranges overlap. We get the tropical species coming in, but the temperate species do well as well. And essentially, it's that mixing of species pools from 2 different biogeographical domains, which give us lots of species diversity or numbers in that region. And then you go along and we got crows, and we will come back to the crows, and then a whole lot of other basically birds which hang around the edge of the dunes. So once you actually add all of that up, you'll end up with quite a diverse bird fauna for sandy beaches and the frontal dunes. Who would have known? But when you actually go back then to your textbook knowledge, and this is where the learning comes in, that sometimes you just have to go out and investigate stuff. What I start here with a little star are what is traditionally seen as being a shorebird, and this is basically what we really got. I mean, one species made up almost half of it, those being the crested terns and the gulls, no surprise then. But essentially, amongst the top 10 species are only 3 traditionally classified shorebirds or waders, and they're not necessarily ranking very high in abundance. So learning is basically happening every time you go into the field, and you just have to sometimes, be open-minded about it. Right. Now, this is a video, I think it comes from Siberia, and I'm just going to play it, and you need to actually spot what is the real relevance or the thing you might spot what actually strikes you about this footage here. It doesn't have a bird on it, I think. Somebody's doing some research and trying to write things down in Russian. That's actually a CO2 meter, so they're measuring CO2 emission from the ground. So what was interesting or odd about that footage? Do you want me to play it again? Anybody? What about all those things flying around the guy? The reason I showed you that is the amazing number of, I think this is actually quite funny, you know, it doesn't work. Is the amazing number of, come on, go away. It's the amazing number of insects, of mosquitoes. Now, my dad always said he lived for a few years up in Sweden, and you know, everybody has this sort of idea. You go right to the north into the Arctic in the summer, and he said the mosquitoes, you know, literally try to carry you out of the tent, you know, if you left it a little bit open. And I was sort of like, no, that can't be true. And some of my mates have gone to Russia in the summer, and you know, it's something which is not very, very pleasant apparently. But remember, lots of insects in the summer in the Arctic, going absolutely mad. Now, when you retire or you have nothing better to do on the weekends, and I'm being a little bit, you know, fastidious here, is you can actually go and study wader birds. And one thing people who study wader birds in the region here do, and everybody can join them, it's actually quite enjoyable really to go along for a few of their meetings, is you track where those things go. You might say, really? Why would I want to do that? Well, here you can actually see is a bird, and it got a little solar cell, and below it is a satellite transmitter, and it got a little antennae. So when you actually track those birds, they all got different names. Each of them, you know, is a different basic transmitter. Nowadays, we get amazing information of where those things go. But we knew that before, because what they do is they basically go between Australia and right up to the north of China and into Siberia, where we just saw that footage about all the mosquitoes driving people bonkers. So essentially, most of the shorebirds which we have in the region, they migrate. And that migration, I mean, that's really Shakespeare, you know, Hamlet, to be or not to be, that is the question, that kind of stuff. So here it's like, you know, to migrate and not to migrate. Ooh. Can you guys actually hear me properly?
Yeah.
Okay, funny, because I got an odd warning thing, whatever. So essentially, 36 of those shorebird species migrate between more or less Siberia and back home, and you know, half of them basically stay here. Yeah, very bad joke. If you ever have, you know, watched the TV series Fat Pizza, it's quite hilarious. Never mind. So almost all of them, all of the migrating species, do a very amazing thing, really. They go all the way from Australia to breed in Russia and then come back, because hanging out in Siberia, there's a fascinating documentary about the coldest place on Earth. And there's this Russian Siberian village, and it gets up to -60. And only if it gets to minus 50 are the kids not allowed to walk to school anymore. Pardon? And I remember, like, we were only, not allowed to go to school when it was like minus, 35. Minus 30 was still fine, but minus 50 is quite a different proposition, right? And that's just for a joke, really. This guy here, they don't really know what they do. They sort of breed out in Western Queensland, and then they migrate to Indonesia for the winter. That's a little bit like going to Bali, if you actually think about it. And this one, a double-banded plover, is completely bizarre. That basically, has decided to abandon the Russian migration and actually goes to New Zealand. God knows why. Bad rugby team, a very good one, but never mind. So, but by and large, this is the pattern of birds we see on our shores, mudflats, and estuaries. And I call it a flyway, and it's basically this broad corridor where birds go back and forth. There's, of course, variation between different individuals and so forth. Now, the numbers are staggering. We estimate there's about 5 million birds involved every singular season to do that, and 2 million of them come to Australia and then go back again. And of course, they all need, wetlands as stopover places and also as habitats when they go somewhere. And there's an international convention called the Ramsar Convention, which aims to protect those wetlands. Now,
excuse me, sorry. Excuse me. Just on those migratory birds, I was reading somewhere that they have declined in numbers quite substantially, like something like over 60% of the birds have declined, the migratory birds have declined. Have you heard that?
We get to that in about 2 minutes and 80 seconds.
Oh, okay, no worries.
So some of the metrics, what I call it the metrics of achievement, are really quite astonishing. You're talking about 20 to 25,000 kilometers round trip. They can fly up to 8,000 kilometers non-stop, which is absolutely mad. They can navigate by day, they can navigate by night. We're talking about just below the cruising altitude sometimes of a Boeing 737. Up to 60 kilometers an hour might not be terribly fast, but for a small little bird it is. And if you actually think about covering that distance, it's quite an amazing achievement. Much of it is sort of regulated by internal clocks which regulate physiological and anatomical processes. And we are still not entirely sure why they do it, but it's probably just switching around between the rich food resources up here and the overwintering ability in Australia. Now, you might actually ask, if I'm a bird up in Russia and I, in the autumn, go south to avoid the very unpleasant Siberian winter, why do I go all the way sometimes to New Zealand or Tasmania or Victoria? I mean, who wants to go to Mexico, which is, I think Mexico is down here, or Moreton Bay? Why not actually hang around in the tropic? And there's a few ideas around. The one is called the competitive displacement hypothesis, which basically says, look, I'd like to actually hang out in the tropics, but there's actually not that many, and this is where the Nice's argument comes in, wetlands and beaches and estuaries anymore where I can hang out. So I simply have to go further south if somebody else has already been there first. Or maybe they track the food because not all tropical areas are necessarily more productive. Other explanations are there might be too much heat stress in the tropics, there might be too many parasites, but basically it's a bit of an unsolved mystery. And this is basically the critical problem which we have at the moment, if you look at that central part, because this is all China. And many of those birds used to use big mudflats and estuaries and beaches in China as stopover places, or even sometimes as overwintering routes. And many of those have actually disappeared because, until not so very long ago, we imported just about everything which is manufactured nowadays from China, and those products had to make their way to Australia. Many of those transport routes are done by ships, and ships need harbors. And where do you build harbors? In shelter locations. So many of the wetlands, which were traditionally used by birds as stopover places en route to Siberia, have basically disappeared because the mudflats are now harbors, or they're now railroads, or they're now office buildings or factories. So this is actually a very, very big problem. Each species, as you can see here, has slightly different migration routes, but basically that pattern, despite some variation, is a common one. Now here's something quite funny. I couldn't really get a better picture, but I'll show you some really, really cool pictures. And that is, look at this bird here. That's a tunlin, and it's just about going to go off for its migration. And look at the big bum here. It's basically full of fat. It's real fat. It's just going to take off. And it's basically like in the old days, before, well, actually, I think I still flew a Qantas 747 last year, actually, over from America. It was the last one almost in service. And when the planes are really fully loaded, just like this bird here, they take a long time to get off, and they go, and eventually get off. So those birds here, before they start on a migration, the internal clock tells them, well, what you actually need to do is feed, feed, feed. Don't actually spend too much time flying, because that uses up your fat reserves. So you want to actually become as fat as possible, that you can still take off to actually make those migrations. That means when they overwinter here, and this is what people don't realize, every time we flush a bird, it actually uses up some of that energy it needs for flying. And we reduce the time it actually has for feeding. Plus, when we actually run cars up and down the beach, and we deal with that in about 2 weeks' time, we reduce very much the prey abundance, because we squash the invertebrates buried in the sand. But what is really, really quite cool, and the flight muscles increase, and even the heart becomes bigger. It's almost like a top athlete, really, is you can have those graphs here, and this is basically before they go off, and this basically as it goes off in 1 month here, this is from the Northern Hemisphere, but never mind, they can become really, really quite fat. But look at this picture here. It's on an old paper, and essentially they found some birds, and this is all happening from May the 3rd, look at this one, to May the 27th. In 1 month, they literally almost doubled their weight. And you can see all that subcutaneous fat here and down at the rump here. So sometimes, and I shouldn't really say that, you don't need statistics. I think that actually illustrates it really quite well. So there's a lot of energy fat reserves which the birds need. And this is key to when we as biologists argue we should actually conserve birds on beaches, because we shouldn't really disturb them and flush them, because they need every singular ounce of basically energy for their migration. People say, doesn't really matter when I drive my 4x4 through them. Well, it actually does, because you can't actually then, build up those kind of vital energy reserves. One thing which is also quite cool, some Israeli researchers studied those little songbirds here. I'm not going to tell you what it actually is called, because the English word is a table, and I could actually never quite figure out who actually named them. Is when they, this is the bird during the day, and this is a bit of a lapse, and then it gets actually dark. So what actually happens is when they sit, when they perch during the migration, they can slow their energy metabolism right down and become almost hypothermic. It's pretty much the same as what bears do when they overwinter, but they do it every single night. So it's actually a very, very clever way of preserving energy. Quite cool, I think, for a vertebrate. Just think about it. If we actually have slight hypothermia as well as humans when we go to bed, but we don't actually lose 4 or 5 degrees. That's for a vertebrate quite a substantial amount of metabolic reduction. Now, there is, of course, a veritable body of literature out there trying to figure out how do those birds manage to get back to Moreton Bay. And we know they get back because they come back with the satellite tracker and the Russia year after year. So it actually requires a reasonable or a very, very amazing amount of navigational abilities. We even actually figured out that birds can fly great circle routes, which is, of course, when you go around, when you basically travel on a round object, the shortest distance is not always necessarily the most direct one. You can actually work it out with geometry and a piece of string. So birds also compensate for wind drift. They probably use the magnetic field, and we see a demonstration on the next slide here. Sun and star navigation seems quite obvious. Birds can detect Polaris light. Some of them remember landmarks. But here's the most fascinating one. I recently read a book about bird physiology, and we always assumed that birds don't really have a terribly good sense of smell, but they actually do. And we don't quite know, whether they actually use it for navigation. But here's actually something which is quite true. When I was a student, I used to share a flat, as you do as a student, like a terrible old place, but never mind, with a theoretical mathematician. I always thought like mathematics is pretty theoretical, but that's actually one step further. So they're completely removed from reality. But never mind, so he had his friends over and they bought 2 cases of beer and sat up all night doing really complicated equations and then said, oh, Einstein got a little bit, 1 decimal place wrong here. That's what I do for fun. But they did also something else for fun. I remember that. They went on long train trips, during the summer, because none of them, of course, had a driving license. Because why would an academic need that? And one of them was actually blind. And I asked him, so you got these long train trips, and pardon me for saying that, but you're blind. So how do you know where you are, and how do you sense the different places and countries you travel to? It's like, well, I smell them and I hear them. And I asked, my mate, who actually was his best mate, said, they travel through, France, and he would actually open the window and he said, we are plus minus 50 kilometers from that city. And it worked every single time. Of course, he could have maybe worked it out by time or whatever. But it is actually a sense which we completely underappreciate. And the sense of smell in birds is quite a fascinating topic, and I got actually an idea for an experiment which we can actually do on beaches using those, when you go to Japanese restaurants and they have in the window display this really cool fake foods. They're actually quite expensive to buy, but they're really good ones. But you could actually, see whether some of the scavengers take the fake ones at the same rate as they would take the real ones, and or we can actually paint some of the fake ones with fish soup, which we actually get from a mixer. Lots of actually interesting ideas. You can actually test the sense of smell in beach birds. Now, sometimes you can actually do the most simple experiment by somebody apparently messing up your laboratory setting. Have a look at this one. It runs for a little bit, but it's well worth persisting with it, because it's quite a mad story, really.
Migratory birds can sense the Earth's magnetic field. They use this inbuilt compass along with visual cues like the sun and stars to help them fly in the right direction. For decades, people have wondered whether electromagnetic noise made by humans could be interfering with birds' magnetic compass. Now scientists in Germany have shown that in robins, at least, this appears to be true.
Anthropogenic electromagnetic noise is everywhere because every piece of equipment with a plug, when you plug it in, it's going to make electromagnetic noise in some frequency range. If you could sense this electromagnetic noise, it will probably be like some kind of rock concert going on all the time.
Henrik's team discovered this effect when they tried to replicate an experiment performed by scientists who study bird orientation. It involved putting robins in a cage at night during the migratory season. Because the birds are so eager to migrate, they'll jump in the direction they want to fly.
You take some birds from their normal home cages, you bring them to your hut where you want to do your experiments, and then you take them out of the carrying case and you put them into this funnel. And this funnel has scratch-sensitive papers on the walls. And then you leave it there for an hour, where it does its spontaneous migratory restlessness behavior, which it only does at night and in the migratory season. After this hour, you take them out of the funnel and you have the results on the scratch paper.
For 3 years, Henrik and his colleagues couldn't see their robins jumping in the right direction.
We were desperate to make this experiment work. So for 3 years, we tried all kinds of things to make this experiment work, but nothing changed it. They were disoriented until one day a postdoc of mine, Schlacher, got the idea to screen the wooden huts on the inside with aluminium plates and connect them to a lightning rod.
By screening the huts with aluminium, the researchers blocked man-made electromagnetic noise from entering the hut. When they switched the screening on, the robins suddenly oriented.
So this is one of the experimental huts that we use for our experiments. And what's fascinating is that the grounding down here can actually be connected and disconnected just by unscrewing this screw. And this means...
Amazing. Who would have thought German technology is screw?
The birds inside this hut will be feeling all the electromagnetic disturbances and they will not orient. If I reconnect the screw so that the aluminium screens inside are connected, then the birds inside this hut will orient. So basically, I can turn on and off the orientation of the birds by either connecting or disconnecting this screw.
Once the team had removed the robins from the cages, they could take a closer look at the scratch-sensitive papers.
So at the end of the experiment, we collect the papers of the funnels, and basically we can then look and see in what direction this bird wanted to jump in and go in. You can see here that this bird is very, very oriented in this direction. There are lots of scratches here, virtually no scratches here. So this is a very well-oriented bird.
To work out what kind of man-made electromagnetic noise was interfering with the robin's compass, the team used coils to artificially introduce different frequencies of noise inside the hut.
So the frequency range that we found effects of is the radio frequency, AM radio frequency band.
I think we all got the idea now. So sometimes you have to be quite prepared to go and look at the bright side, and some experiments are actually very, very simple. You don't always need the most technical equipment. Much of it is actually in your head. Now, here's something quite curious, as I have said, why we as marine ecologists, and you have to think back now to the lecture we did last week on estuaries, and remember we spent a great deal of time talking about all the little invertebrates sitting in the mud, and we talked about that they funnel the energy from all the primary producers to fish and birds, and here we have the birds. So, high productivity in estuaries ultimately lands up in birds and fish, but the crucial intermediate link are the invertebrates. Now, how do you actually get them? Well, the cool thing about birds, and this is also the annoying thing, the reason botany is a lot simpler than doing zoology, but also a lot more boring, is plants don't really generally move. But animals do, and nothing moves more than birds. However, when you think about it from an ecological perspective, a moving predator who can quickly respond to changes in the abundance, availability, or the nature of prey organisms over hundreds of kilometers because they can fly is the ultimate consumer in food webs. We are quite, was just checking that nobody takes my boat. It sounded fun. We are, of course, often very much impressed by sharks traveling long distances, and of course they are a perfect killing machine in the water. But birds are even better because they can very quickly respond by being able to fly, and they feed on just about everything which is in intertidal areas, and also on fish. We got lots of diving birds, and we got actual swimming predators being the penguins. But if you actually look at the intertidal birds, the one thing which strikes you is, and you can spend probably collating hundreds of those images, and people have actually realized that the early naturalists, this comes from the Encyclopedia Britannica, if you take a range of shorebirds, what actually is the most amazing? Yes, Cherise? Is the most amazing adaptation is that they all have very, very different bill shapes. I mean, you look at an everset here versus a semi-palmated plover. Or we even got little spoon-billed sandpipers. Look at this guy. I mean, I don't think he ever gets, a date when he goes up on Friday night, but never mind, poor guy. Or like a really, really strong, powerful beak. This one obviously used for probing and so forth. Now, every textbook has those, and the key message is that there is no invertebrate which can bury in the mud or in the sand which is not reachable by a bird. So you have a suite of predators which can probe the sediment at all depths, from being surface feeders here, like those little stints, to all the way down to 30, 40 centimeters of a ghost shrimp, which is in Australia called a yuppie, to actually be extracted from the sand. Now, I just put those in because it's kind of in a very nice video. We usually distinguish between two types of feeders. You're either a smallish guy, usually with short beaks and a very big eye because it's all done visually. And those are surface feeders, and some of them have a very peculiar behavior. They actually, look how it trembles his foot, and that makes the invertebrates in the front move. There's a little worm and goes, whoop, what is that? And that little movement is enough for the plover to actually get them. Isn't that cool? So that's actually a very, very cool feeding behavior. Some of them, however, don't do that trembling, and they just run very, very systematically in a zigzag pattern and look for invertebrates. Here we go. And here is the other extreme, which is a probing feeder. It's a whippoorwill getting, I think, crabs is probably wrong. They'll go for ghost shrimp. But look at the difference in the feeding behavior here. How did I get this up then? Come on. He's going back. When he actually finds something, he's probably going, he could actually be going for soldier grapes. Come on, perform. Be a good boy. Here we go. See that deep feeding? So basically, from an ecological perspective, that great diversity of feeding modes, of feeding appendages, plus the fact that they can fly And let's not forget that that is for a predator the ultimate advantage. Makes birds enormously important in the energetic of shallow water coastal systems. Here's actually an oyster catcher trying to get at a pippy, and that's my photograph. Could be a little bit sharper, but it's quite a good one. Now, I'll show you something quite peculiar. And it's peculiar because you actually think, how did these birds actually survive all those thousands of years of having a very, very precarious, I would say, type of reproductive behavior? We have 5 species of birds, which are called beach nesting birds, which nest only on ocean-exposed sandy beaches, i.e. high-energy shores, usually on the upper beach and in the dunes. It's the hooded plover, which is Australia's most endangered plover. Red-capped plovers, we have lots of them, but they're actually extremely cute, which I will show you. We've got sooty oyster catchers, not so many on the Sunshine Coast. There's a few pairs hanging around because they prefer rocky shores. We got the beach stone curlews and the pied oyster catcher. Now, if you actually look at some of those species, and we have done quite a bit of work on them because I think they're quite cool, is that oyster catchers are found on every beach around the world. So they have radiated. Something makes them quite successful. And it is actually probably their feeding behavior by being able to prise open pippies like clams. In Australia, we have a bit of a problem. I sit on an expert panel in New South Wales, which is actually, I hate to say, a little bit more advanced in that, trying to determine what the population size is, because there is quite good indications that they have gone down very, very dramatically, and that actually comes back also to what Denise pointed out. And what is really so cool on that is that they manage to bring up young in the most unlikely of circumstances by breeding really at the edge of the beach. And this is actually, I selected that particular footage here because in the birding community, people often talk about ethical birding. And that means you actually go out in an environment and you're not interfering or disturbing with the natural behavior of the birds. And this guy here, even though he got some nice footage, is in my opinion a complete idiot. Let's have a look at that. So I know exactly where it is in the Fraser
Chicks with them.
Peninsula.
Their behaviour is quite guarded, but they're letting us get quite close, which is rather lovely. They're quite common in Australia, especially in south areas of Tasmania. They're a wading bird, and the name oyster catcher is, I believe, a misnomer because they don't actually eat oysters.
The birds are not disturbed right now, but there's no need to really stalk them at a few hundred meters. So this is unethical birding, and this is how they breed. They literally just create a very shallow scrape on the upper beach, and there is no nest as such. But look at the small ones, aren't they extremely cute? And of course, if we disturb them, what actually often happens is that the adults try to run off to distract the predator in a different direction, and then the chicks get lost, or they actually get taken by birds of prey. So again, human disturbance is not something which one should actually take too lightly in those circumstances. I mean, look at this idiot. Okay, so this is a perfect example of how not to go birding if you ever wanted to. Right. Now, and they're also territorial, they breed in pairs, and the population in our parts of the world has gone really down dramatically. I've been going to Fraser now for 20 years, and when we took a class up there, we usually used to see on one run between 30 and 40 oyster catchers, and the last 3 years we have seen 3 or 4. So they have declined in less than probably 15 years by an order of magnitude, which is very, very disturbing. And this is basically a nest. And because the nest is so simple, we can actually use that to our advantage, because we can actually use quail eggs, which look very, very much the same, and we can place them in different parts of the environment and monitor what actually happens to them. This is a sooty oyster catcher, and they are basically the rocky shore equivalent. And probably not as much endangered, simply because they live in habitats which are not impacted by 4x4. So this is one of their advantages. Now let's look at this fellow here. This is a red-capped blubber. We find dozens of them on Fraser Island, and here is the same blubber doing the breeding thing. And look at the chick here, but watch those images very carefully. Now, when you look at this image, what do you note as an incredible feature of that picture? Anybody?
Very camouflaged.
Pardon?
Very camouflaged. Looks just like like it's patterned like the sand. So I guess it's an adaptation to, to stop predators, I guess.
Yeah, it's beautifully camouflaged. But what else? I give you a clue. Look at the size of the sand grains. Now, if you work out the size of the sand grains, they're probably about 200 micrometers across. That chick is not terribly much bigger than a 50-cent coin. And, in terms of smallness and size and cuteness, it's very, very difficult to actually beat those guys. And you should actually not basically underestimate that. So when you have species who actually have a very precarious nesting paper, which usually only have pattern, I should say, which usually only have 1 or 2 young, any disturbance is likely going to be a big mortality risk. Because what the adults can do, they can either abandon the nest, or when the adults go off, try to attract the predator, other predators strike in, and quite often they overheat very, very quickly when the adults not sitting over them. So all things are being tried. People are building like beach shelters and so forth, and I will show you some examples of what you can actually do with them. Now you might say, all right, Thomas is just waxing on lyrically here about birds because, there is a great emotional connection to them, and they are aesthetically very pleasing. And who wouldn't actually want to actually invest time and energy to actually saving something like this? And again, I tell you, if you want to go out and preserve habitat at large, using iconic species is not a bad idea. Or like this. Here's an albatross with a chick. However, you might say, well, I'm a hard-nosed ecologist. I'm not really in the game of being, emotionally swayed by birds or whatever it may be. Well, I did send you that, and this is actually perhaps at the moment the most well-published and famous bird ecologist. He's a Turkish guy, Sekaricilo or whatever. I can never pronounce that. But what birds do is they have an amazing range of ecosystem services. They're pollinators, they're seed dispersers, but they also link different ecosystems, and they remove rotten animal flesh. They are literally a public health police by taking away carcasses as scavengers. So they, in the natural world and also in a human modified world, they fulfill a large range of very, very important ecosystem services. So we might sort of preserve them not only from an emotional point of view, but purely because they are ecologically very important. Now, I wrote a long list here of why you might want to actually preserve birds. And this is what you read everywhere. But ultimately speaking, I said today, I had a Zoom meeting with somebody and said, well, I'm probably the only ecologist at USC who has actually written a philosophy paper, and I got actually a doctorate in philosophy. And when all is said and done, by the end of the day, it all comes down to ethics, because we can argue that there is no ethical or moral justification to endanger populations or a species. All the other ones are, of course, important, but the final arbitrator of conservation is an ethical reason. Having said that, what can we do? There's an international agreement. There's lots of legal instruments to protect important wetlands. It's called the Ramsar Convention, and we have one in Moreton Bay. We have one up in Harvey Bay, the Great Sandy Straits, and essentially one tries to preserve mudflats and the adjacent vegetation for birds. The problem is it's a legal instrument, but it doesn't always have much applicability in a particular country. You can say, I signed up to the Ramsar Convention, but there's no punishment. There's no instrument where somebody can essentially be held accountable. And that basically means that many of the wetlands the world over are quite threatened, even though we have these wonderful instruments in legal ones. And we got the Ramsar Convention, we got the Convention of Biological Diversity, blah, 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 blah. So you might actually say, right, this is all a little bit, daunting. Does it really work? Well, it does work, but some stuff can also be done at the local level. And I try to show you now a few things which people completely forget. And they're quite simple ones. This is actually an experiment we did a few years ago on Stredi. And you can see we put these cameras up and they trigger automatically when a larger animal comes in. And you can see the eggs here. Those are quail eggs. They're not eggs of oyster catchers, I should say. So we bought 1,000 quail eggs, which is kind of funny from a Russian guy on a Gold Coast, but kind of an interesting experience. And you can see up to ghost crabs. And we never thought whoa, ghost crabs go for eggs. That, of course, would not actually be a problem if there would be a parent bird guarding the scrape. However, if you chase them off, it could actually be a problem. And here we go. Can you see the crow with the with the thing going off? We just got it on camera. And you can also see another very important instrument here for scientific research. It's called a coconut, which you can actually use to mark your sites unobtrusively. Here's another crow going straight for the eggs, and look what mess they make. Some of you would have actually written about crows, and I know it's very difficult when you not go on a field trip, and this is the best I can do. And this is actually evidence if you have too many crows, even though they are native species, they become actually very problematic because they start to predate the nests, being the eggs, and sometimes the chicks as well, of shore nesting birds. This is a fairly obvious one, and I just put that in. Of course, there's not terribly many birds left in Mooloolaba. But the general idea that we actually lose at a rapid rate coastal habitat is probably the single biggest threat. And, we can talk about this at length. That seems obvious in most cases. Also, what is actually fairly obvious is that guy here. It's the fox coming after the crows and eating the rest of the eggs. And we kind of have in Australia taken on the view quite widely that fox control is probably something we should do because, as an introduced predator, a mesopredator, middle-sized, they cause a lot of damage. However, and this is, I think, in my opinion, a very, very valid debate, there's a new line of thought, a new school of thought, that the way we currently do it with poisoning is I think, barbaric, and it should completely be outlawed. I mean, putting highly toxic substances out who actually kill a lot of other things and basically cause the fox itself, the individual, to die a really, really agonizing, painful death is not something we should do. We should just basically trap. Moreover, we have just completed a paper 2 years ago, and it's going to go out and be published next week, that actually showed that fox control has absolutely zero zilch influence on fox numbers. It was the most uninfluential variable of all the ones we tested. It's quite interesting, really. So the other thing is, of course, that's my ex-dog, Schlacher, bloody bastard, is we seem to actually, taken quite a, how did that one get answer? Foxes, dogs, cats, politicians. We seem to have taken quite a dislike to foxes, and quite rightly so, and also to cats. But what about dogs? There's a big school of thought now out there about what dogs do. And here's Schlacher going on a research trip. And when you go to a beach, what actually happens is, where there are dogs, the car stops, back door opens, or the canopy open. Dog jumps out, looks left, right, and right, and actually chases the birds. And I have actually seen a dog on the beach killing a bird. Not a very pleasant sight. And people actually put it on YouTube. I mean, look at this. And I love dogs, don't get me wrong, but dog ownership or the dog handling has to dramatically improve in Australia, because it seems very unbalanced that we take a very strong view about cats, we take a very strong view about foxes, but we are perfectly fine with dogs. It was like, oh, look, he's going to have fun. And here is a challenge to all of you. When I came here, being a good beach ecologist, I went to the beaches around the joint, and I actually thought, where are the birds? There's actually very, very few birds on the beaches of the Sunshine Coast. And then I sort of realized, well, there's not terribly many birds, because there are dogs everywhere. And where there is not dogs, it's an urban beach. So essentially, shorebirds in our neck of the woods simply don't have any chance. So I can show you then some work we have done on dogs, and this is actually a subject on the next lecture. I'm just trying to set here a little bit of a thought bubble, of a thought exercise for you guys. Now, this is an oyster catcher being run over on the beach. Very, very confronting sight. And I learned something interesting. I showed that particular slide. That comes from Moreton Bay. We found that. I showed that particular slide at a bird conference, and I was an invited speaker there, and they were all very nice to me beforehand, and then we had tea. And normally you stand around with a cup of tea and a biscuit, and everybody's terribly polite, or chap and all the rest of it. And I sort of realized is that doesn't really work that well, does it? I sort of realized that people weren't really talking to me. And I said, what the hell is going on here? And what actually went on, somebody eventually said, like, you made a really, really big mistake. I said, what did I do? Did I offend somebody? He said, yeah, you offended everybody. And I said, oh my God, what did I say? He said, no, it was all very interesting. It was all very good. But he showed a picture of a dead bird. And I said, yeah. And apparently, that's not what you do, because birds are sacrosanct. You don't actually show dead ones. Isn't that kind of interesting? No, I don't take it as a personal critique, but it is, I think, very, very interesting that people hold birds in such high regards as in a particular certain sector of community, that it is kind of unethical, or no, not unethical, but it's against social norms to show a dead bird. Now, this is an interesting challenge, and we can chat about that, and it's actually almost a bit of a problem that we can't actually chat physically. And that is, how many birds get killed directly in vehicle strikes is a mystery. And it's a very, very big problem to research because we don't actually have that many left anymore, and you would have to be so lucky to actually come across one. We were actually unlucky here. And so what I tried to do is devise an experiment. I had 3 girls. Well, I still have 3 girls, but they're bigger now, so they don't actually go. You can't actually use them as slave labor anymore. So I actually got them to make fake oyster catchers. They're actually at the university, but they actually did an incredibly good job. They went to their home, decorating shop, and they got the balls and the feathers, and they made beaks, and they looked really, really, really good. And what we tried to find out is if you put fake oyster catchers out on the beach in vehicle ruts, how would people react when they come along? Because the problem is the oyster catchers in the evening, they go up the beach and then they sit and crouch down in the ruts made by cars because it's less wind and it's warmer and they feel protected. And then the cars come along, they're trying to get the ferry, and they run straight over them. So we put these fake oyster catchers in vehicle ruts, and each one had a camera, a GoPro up in the dunes. And then we hid in the dunes, and we set about 10 of those up along the beach, and we thought, this is the easiest experiment ever. 20 oyster catchers, 10 GoPros, and I collect them after 3 hours. And guess what actually was the most? So we actually expected that either people go around, or they stop, or they run over them. And we tried to figure out what the most common behavior is, and then we sort of, the next day we put them out of the ruts and try different things. It's like it's such a great experiment. Guess what actually happened to all but 3 of the fake oyster catchers? And we have it on camera. It's actually quite interesting. Anybody has a guess? Did they get run over?
Did they get stolen?
Exactly. Every single one of them got stolen. People just stopped and said, oh, nice. Boom. And off they went again. I couldn't believe it. I mean, I thought, well, maybe 1 or 2, but every single one of them. Of course, that was a big problem because, we went there for a week and then the girls cried. And so had to buy lots of ice cream. But it's an interesting behavior as well. So people did recognize that the bird didn't move and they stopped. But when they stopped, that doesn't sound like it's just some stupid experiment and they ran around, but they actually took them home. So here you go. So I'm trying to do that again, but I think we do it. We just have to actually make more birds. So here is an example to finish off. Next week we're going to talk a lot about the actual human impact research on birds on the coast here. I'll just give you a bit of a teaser here. And here, but I'll give you an example of sometimes the simplest things can actually work quite well. Now we are a little bit prohibited at the moment from traveling, but for those of you who have gone into Los Angeles and you drive up the coast here, you come to a place called the University Santa Barbara, and you've got a university. If you ever have a chance to study abroad or go somewhere in America, I mean, it would be very, very difficult to find a more beautiful campus. This here is the biology lab of my friend Jenny Dugan, and they literally go with their buckets right down to the beach. There's steps. It's there. And that entire area here is the campus on a sandy beach. There's a little lighthouse here. And there's a sort of estuarine lagoon. And what actually happens is right on this beach here is is a nesting place of, this is the piping plover. It's the American equivalent of the hooded plover, and it's a highly endangered bird, nests on the beach and so forth. And this is a very popular beach because it's right on the campus. Look at all the people. So people said and the piping plover numbers were going down. They're going down all over the American shores. They said, okay, what we do is, you tell people be nice to plovers. But then I said okay, you put up, one of those spotting scopes, and there's somebody there that called it a docent. I don't know why it's a docent, like this, and it basically said like, look, those are the birds. Can I actually tell you something about it, and so forth. And they put a very, very simple rope fence around the colony. And what really, really astonished me is, I don't know, maybe Australians would actually, Ben, what do you reckon? Would we actually steal the fence? Probably.
Yeah, probably. Steal
Yeah.
anything that's not tied down.
Yeah, you probably steal the fence. You probably make a fire with the wooden stakes, and then you call actually the people here a dickhead, and that's probably all a good day's work. But I think that the trick is really to have this kind of interaction where you actually tell people something about it, and totally amazing. I mean, look, nice summer day in California, and people perfectly nicely, stayed out of it. I mean, there is 2 of them in there, but it really, really worked. And you might say, "Oh, come on," Well, it just happens to be the case. This is the only upper beach terrace. I was there in January this year, just before actually all the shit happens, working with Jenny and Dave on those plovers. And that is actually a perfect breeding place because there aren't that many estuarine lagoons which create this upper tidal flat. So people stayed out of it. They might say, really, does it actually make a difference? Well, you can basically go there, and this is what some of the students did, and you record how many disturbance events, basically when did the birds fly off or run off, occurred, over time. And this is basically, that is over, I think, 5 or 6 years. And this is basically before the protection. You can see quite a bit, and then whoop, it went down. So the birds were not that, often that severely disturbed. So it also works. But ultimately, it's all about numbers. And here is the graph of the numbers. Before the protection, those are the light gray ones. And you can see for each month, there's a seasonal variation because they go up to Canada and then come back again. Again, same thing. They go up and into the Arctic. They don't go to Russia, of course, because they're American birds. They probably, are not allowed to go there. So they actually go to Alaska. And as you know, Alaska was actually part of Russia. And the Russian Tsar, because he lost so much money gambling in Vienna, this is actually not a joke, he needed money. So he sold Alaska to the Americans. Can you actually believe it? Never mind. So the plovers still go up there. And you can see for every month, the dark bars are the numbers after the protection, and you get about a 30% gain. You might say a 30% gain is so much, but you know what? The cool thing is that the investment is actually very low. And people who maybe gain some insight and some knowledge hands-on at the spot about what works in this kind of form might actually go to another place and say, I might actually not take the 4x4 onto the beach today. Or I might not wander around those tidal flats here if I see little plovers. So it's the spillover effect. And I kind of quite like it because we can talk about spatial conservation planning and million-dollar investments, but sometimes working with people, because people are the ultimate solution and problem to those kind of things, will actually work. So I think this is actually a very, very encouraging example of that we can actually do things which are simple and make a difference. So the world might not always need $1 million, because each of you can actually work towards a better outcome. It's almost like a pastoral evangelical kind of message to end. And next week I'm going to show you some really examples of shorebird and other beach work from around the coast here. Right, thanks for listening. Open for questions. Hang on, I stopped the recording.